Assalamualaikum and hi to Dr. Hadi and all my fellow classmates. My name is Amir Zahran bin Ghani and today our group will be presenting on deep foundations. Before we start, let me introduce my group member who will be presenting with me today. First, Muhammad Iqbal bin Jalil. Next, Nur Aina Nafisah binti Ahmad Faisal Anwar. Then, Nur Alia Idina binti Azman. And lastly, Nur Nafisah binti Ahmad Zain. Now moving on to the introduction, this study evaluates the advanced deep foundation system implemented in two of Malaysia's most iconic super tall skyscrapers, which is Merdeka 118 and the Exchange 106. By analysing their distinctive geological challenges, ranging from Kuala Lumpur Canny Hill Formation to highly volatile limestone cavities, this research compares the engineering design, execution methodologies, and stringent quality control protocols required to safely stabilize and support unprecedented vertical and lateral structural loads. Now let's look into the project background, starting with Merdeka 118 overview. Merdeka 118 is a historic landmark mixed-use development standing at approximately 678.9 meters with 118 stories, making it the second tallest building in the world. It was developed by PNB Merdeka Ventures Sendirian Berhad and constructed by Samsung CNT Corporation as the main contractor. Moving on to the Merdeka 118 geotechnical approach to safely transfer the unprecedented structural loads generated by these super tall skyscrapers. The design incorporates large diameter bore pile up to 2.4 meters in diameter and extended over 60 meters deep, and that are fully integrated with a massive pyra foundation system. So we move on to the Exchange 106, rising to the 543.6 meters with 106 stories. This iconic skyscraper served as the visual centerpiece of the 70-acre Tun Razak Exchange, which is TRX Financial District. Developed by Mulia Property Development, the project was constructed by China State Construction Engineering Corporation, which is CSCEC, as the main contractor. Looking at the Exchange 106 geotechnical approach, due to highly volatile and complex Kuala Lumpur limestone geology at the site, which often contain natural cavities and uneven bedrock levels, EDP Consulting Engineer design an ultra-deep pyra foundation UDPRF to safely support the massive structure.
Next, I will explain on case study. So for case study 1, we choose Merdeka 118, which was located in Kuala Lumpur, and it is the second tallest building in the world, standing at 678.9 meters with 118 stories. And the project was developed by PNB Merdeka Ventures. Due to its extreme height and massive structural loads, the building used large diameter board pile foundation combined with pyra foundation to provide sufficient strength and long-term stability. Okay, so for the construction method, the construction started with site investigation to study the soil and rock conditions. And after setting out, temporary steel casing were installed to prevent borehole collapse. And then rotary drilling rigs excavated board piles over 60 meters deep, and polymer slurry was used to stabilize the boreholes. And after cleaning the boreholes, reinforcement cage were installed, followed by concrete placement using the trimming method. And finally, pile testing was carried out before constructing the pyra foundations to complete the deep foundation system. Next, I will explain about the main problems faced during the Merdeka 118 foundations construction and also the solution that has been used. So the first problem was weak soil, which caused the boreholes to collapse during excavation. And to solve this, polymer slurry and temporary steel casing were used to stabilize the boreholes. And the second problem was groundwater intrusion, which affected the drilling process. And this was controlled by using polymer slurry to keep the borehole stable. And another major challenge was the extremely heavy loads of the 678.9 meter tower. So engineers used large diameter board piles together with pyra foundations to safely transfer the building load to strong rock layers. And since the project is located in urban area near to the heritage building, board piling was chosen because it produced less vibration and noise, reducing the impact on nearby structures. And finally, to ensure the quality and integrity of the piles, several tests including MLT, BDSLT, and sonic logging tests were carried out to verify the pile performance.
Assalamualaikum. First thing first, my name is Nurafsha binti Mazin. Now, I will present our second case study, which is the Exchange 106 located in Tun Razak Exchange, TRS, Kuala Lumpur. The Exchange 106 is one of the iconic skyscrapers in Asia with a height of 453.6 meters and 106 story. It currently one of the tallest building in the Southeast Asia and was developed by Mulia Properties Development. Due to its extraordinary height and massive structural load, the building required a highly reliable foundation system. The project adopted the Ultra Deep Pile Rough Foundation (UDPRF), which combined a large diameter bore pile with a reinforced concrete rough foundations. This foundation system was selected because the site is underlain by Kuala Lumpur limestone, which contains cavities and uneven rock formation. Let's look at the construction process of the bore pile and rough foundation system used in the Exchange 106. Step first is site investigations. Engineer carry out geotechnical investigations, including borehole drilling and laboratory testing, to identify the soil and limestone profile as well as detect any underground cavities. Secondly is site preparations. The construction area was clear, temporary facility were installed, and the site was leveled to prepare for piling works. Thirdly is bore pile constructions. Large diameter boreholes were drilled to the required depth using specialized drilling rig. Any loose material inside the borehole was cleaned to ensure a stable foundations. Next, step 4 is reinforced cage installations. The prefabricated steel reinforced cage was carefully lowered into the boreholes and positions correctly before completing. Next, step 5, a concrete placement. Concrete was poured using the trimming method from the bottom of the boreholes. This method to prevent segregations and ensure a continuous and high quality pile. Next step is pile head treatment. After the concrete head hardened, the pile head was trimmed to the required level to expose sound concrete and reinforcement for connections with the rough foundation. Step 7 is excavation for the rough foundations. Excavation continued until the design level was reached, with temporary support and dewatering provided where necessary. Step 8 is rough foundation constructions. Reinforcement was installed, followed by the casting of the massive reinforced concrete rough, which distributes the building loads evenly across all bore parts. Next step is quality testing and monitoring. Integrity test, pile load test, and continuous monitoring were carried out to verify the strength, safety, and performance of the foundation. And lastly, step 10 is superstructure constructions. Once the foundation met all design requirements, constructions of the 106-story tower proceeded safely and on the completed foundation system.
Hi, my name is Nur Aina Nafisa. Now I will talk about the challenge and solution for this case study. Every construction project comes with its own set of difficult. Here are the main challenges we face and the solution we applied. For limestone cavities, we discovered underground voids that could weaken the foundation. To solve this, we carried out detailed ground investigation, probing, and grouting to strengthen the soil. Next, variable bedrock levels. The depth of the bedrock was not consistent across the site. We adjust the depth of each bore pile according to the actual level encountered. Massive rough foundation concrete. Pouring such a large volume of concrete required careful planning. We use multiple batching plants, concrete pumps, and strict temperature control to maintain quality. And lastly, high structural loads. The building heavy weight demand a strong foundation. We use large diameter board piles combined with a reinforced concrete rough foundation to safely carry the load. Now we move to the next slide. Now let's analyze why this solution worked effectively. First, load distribution. This combination of board piles and rough foundation allowed the building waste to be transferred past weak soils down to the solid bedrock. Second, settlement control. This system minimizes both total and uneven settlement, preventing crack or tilting in the structure. The third, geological risk. Our design adapts to difficult soil conditions, including limestone cavities, similar to those managed at the Exchange 106 project. Lastly, investment value. Although the foundation requires high initial cost, it ensures long-term safety and durability, making the investment worthwhile.
Hi, good morning everyone. Now I will present the comparative study between Merdeka 118 and the Exchange 106. So, this comparison focuses on three aspects: the construction method, performance and cost, and the overall effectiveness of their deep foundation system. Right. Next is comparison of construction method. So, for both projects, they use bore pile foundation because they are suitable for supporting super tall buildings and produce less noise and vibration. However, Merdeka Tower use a large diameter bore pile with polymer slurry to improve borehole stability. In contrast, the Exchange use an ultra-deep pile foundation with rock probing to overcome the challenging limestone ground condition. And lastly, comparison of performance, cost, and overall effectiveness. In terms of performance, both foundation systems successfully supported the heavy structural loads and provide a long-term stability. However, both projects involve high construction costs due to advanced equipment, specialized materials, and extensive testing. Overall, both foundation systems were highly effective because they were designed according to the specific site conditions and project requirements.
Thank you to the previous presenter. Now to wrap up our presentation, I will present the conclusion. So in conclusion, advanced foundation system like pile rough and large diameter board pile are absolute vital for stabilizing super tall skyscrapers against immense vertical and lateral loads. The success of Merdeka 118 and the Exchange 106 proves that complex geological challenges such as volatile limestone cavities and unpredictable soil profiles can be permanently mitigated through site-specific engineering adaptation and rigorous quality control testing. Ultimately, while this highly technical foundation works require massive capital and resource investment, they are indispensable for ensuring long-term structural integrity and engineering safety. That concludes our group presentation video. Thank you so much for watching, Dr. Abdul Hadi, and have a great day ahead.